Okay, so mostly I want to use these two problems to be able to connect some of the other things we have talked about, um, especially like with the graphs and the calculator work that we've been doing. So the first thing when we look at these, you still want to check for things like greatest common factor and stuff, although it doesn't matter quite as much. It's just a good habit to get into. I'm gonna start this one the way we were starting them when we factored them. So if we think about that idea of that X method, and you, let's say you were just trying to factor or trying to solve this problem and you wanted to start by using this X method because maybe you like it, you would go through and say, well, this has 1 times -7. So I'm looking for two numbers that multiply to be -7, but then add up here to be a -4. And so hopefully if you were going through this process, you would realize, the only two numbers that multiply to be 7 are 1 and 7. And even though I could make a -7 happen if I multiply them, there is no way to turn them into a 4. So that would not work. There's no way to combine 1 and 7 to turn them into a 4. So I basically know then that means that this is not factorable. So I cannot factor this. Which means I have to use a different method, like quadratic formula. Some students love quadratic formula. They really, they like the idea that it works for every problem, that they have to just memorize one thing and they don't have to go through so many steps and things. But if you're going through the quadratic formula, then you're going through that long, huge formula and plugging in the right numbers. So let's go through and pick that stuff out first. So first I need to know what A is and what B is and what C is. So just to point out, I'm going to switch colors. This number in front, so it's ax squared plus bx plus c. So that means when I'm looking through these, the A is this number in front here, it's a 1. And then B is the number here in front of the X, so that's -4. So I have to take the sign with it. And then C is the number at the back by itself, the constant. And again, I have to take that sign, it's a -7. So A, B, and C are these. And then I want to go through and put up the formula. So let's go through that story from the video, which is once there was a very negative B, and his mood got brightened. So his mood got a little bit more positive because he got an invitation to the radical B party. And at the radical B party, there was going to be B's square dancing. And they were also going to be playing cards, but their deck, unfortunately, was missing 4 aces. So they're playing cards without the 4 aces. And the party is going to be so much fun that everyone's going to stay and it'll be all over at 2 a.m. So that's the formula. I've used it bazillions of times in my life. So I definitely have it memorized, and it helps. It just helps to have it memorized, but you can obviously always look it up and find it online, unless you're in the middle of a test or something. All right, so I'm going to leave blank spots then where my variables are at. That way you can see where I plug them in. I'm just taking out the A, B, and C and leaving behind parentheses. Okay, so here is my, like, the skeleton version of the formula. And so if I take everything and plug it in a different color, then let's put in, for B, obviously that's -4 and -4. And then so this is -4 times A and then times C. And then on the bottom is 2A, which again is 1. So really this is just PEMDAS. It's go, or if you learn GEMDAS, which I've taught my kids GEMDAS before, that idea of grouping symbols comes first. This is a good example of one that has a grouping symbol, right? Because really a square root symbol is a grouping symbol. So this would be one of the first pieces that you'd want to handle, is this stuff that's underneath the radical, and hope that it gives you a perfect square. If not, then that ends up with an answer that's a decimal. So now I think is a good time. Let's jump into Desmos and remind you of what it is that we're looking for. Hold on, give me just a sec. So if I'm looking at the graphing calculator on Desmos, if I type in what I started with, which is that x squared minus 4x minus 7, so that graph looks like this. And so if you look at it, there are 2 places, because of that bowl shape, it crosses the x-axis twice. It comes down and crosses and then goes back up and crosses again. And the two places it crosses the x-axis are the solutions I'm looking for. Because I didn't write it, but I could have. This is really equals x. You're really solving for what x is when y is 0. So it's this point. So negative 1.317 and this point, which is positive 5.317. So that's what I'm expecting to get. That's one of the ways that you could kind of check your work and make sure that you're doing things right. I also wanted to point out that we did talk about how you could build this equation just by typing it in. So if I put in negative b plus or minus, which I can put a plus sign or a minus sign, I can't put them together, but that's okay. I can always change it if I want to. I can type in that radical, and so then it's b squared minus 4ac. And then if I'm trying to make a numerator, see how it filled in the parentheses for me? I'm going to divide by 2a. So I can build this formula into decimals. And the cool part is now I have these sliders where I can change b to be whatever number I want. So as you're working through 10 problems, then you could just change them as you go. So I did that here in this tab before class started, just to kind of give you an idea of how it would work. So if I plug in a as 1 and b as -4, and then c as -7, then it should, oh, sorry, I clicked the wrong thing. C as -7, try it again. Then you'll see that it gives you those two answers that we saw in the graph, remember? So when we typed in the equation, x squared minus 4x minus 7, these were the 2 points that I got, were these two answers. So I got -1.317, which is here, this -1.3166, blah, blah, blah. It's irrational, so it keeps going. And then this is 5.317, again, rounded because this is an irrational number. It really means that that square root underneath is not perfect. So let's go back to the problem and start doing this order of operations just so you can see me do it, even though you can use a calculator for it, because it's still part of the process of practicing the math that you're doing. Negative times negative in the 4 situation here. -4 is really like the same as saying a +4, plus or minus. And then I have that square root to deal with. So underneath this, I have -4 times -4, which is 16. And then the part I always made mistakes on when I was in school was this part, because I made mistakes with the sign. Signs were always my issue in school. I have 4 times 1 times 7, but 2 of those are negatives, which means that they're both going to cancel each other out to make a positive. So my answer here is going to be plus. And then 4 times 7 times 1 is just 28. All over 2 times 1, which is just 2. When I keep simplifying here, 4 plus or minus the square root of whatever 16 plus 28 is. So 16 plus 28 is going to be 44. And so this is why you get a decimal. This is why the decimal exists, is because this is a non-perfect square root. Non-perfect. So it's irrational. There is no decimal that represents it. It's a decimal that keeps going forever and ever. And that's why you end up with those two answers on your calculator that we were looking at, where it is a big long decimal that gets rounded. Okay. Hopefully that seems good. Let's do the other problem. All right, so this was the other problem. And on this one, I definitely wanted to be able to make the connection here that if you try to go through the X method on this one, so I'd say 1 times 10, so a product of 10, and then a sum of -7, this one does work. So this time I can find two numbers that multiply to be 10 and add to be -7. If you have been practicing these a lot, you might come up with them real fast, but it's -5 and -2. Because -5 times -2 is where I get +10, but -5 plus -2 is where I get -7. So I know from my past work that I could use the shortcut on this and factor it right away and say x minus 5 times x minus 2. But keep in mind, I'm trying to solve, not just factor. So I would need to go through then and solve for these, set them equal to 0 and say that x equals +5 or +2. So these are my solutions. I'm going to still go through this quadratic formula though, because I do want you to still like see it in action. So I have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then I'm going to come over and pull out a, b, and c. So a again is 1. B is -7 this time, and then C is +10. So the 1, the -7, and the +10. So when I plug these in, it's -7, and then I'm squaring -7, and then multiplying 4 times 1 times 10, AC, and then 2 times 1 on the bottom. So -7 this time is a +7, plus or minus the square root of 49. And then 4 times 1 times 10 is 40. There's only one minus sign, so it's a -40 all over 2. And so now you can see this does become a perfect square. This becomes the square root of 9. So that means I'm going to have a whole number this time because it's perfect, which is why my answers here are whole numbers, is because I ended up with a perfect square. And so then I divide by 2. So this represents 2 different solutions. I'd have to split this and say, okay, 7 plus the square root of 9, so 3 over 2, or 7 minus the square root of 9 over 2. And so that's where you end up with 5 and 2, right? Because this is 10 divided by 2, which is 5. Sorry, my pen's like acting crazy. And then 4 divided by 2, which is where I get the 2 from. So I know that I end up with these same 2 answers. I can kind of check my work that way. The other thing is we can look at the graph, right? So this time I'm going to change these. So I had 1 here. I have -7 and then +10. Right? And then I'm going to change my equation. So -7x plus 10. So I should expect to see the x-axis being crossed at a +2 and at a +5, just like I did. So hopefully this kind of makes a connection for you about the factoring quadratic formula, how it looks on the graph, and also how you can use the calculator to your advantage.